Good afternoon. In this lesson, we'll be talking about drawing items in probability without replacement. So they will differ a little bit than what we've been talking about. We've been assuming that all of the other questions, that once I draw an item, that I put it back in and that the probability remains unchanged. These are a little bit different. So we start off with the infamous marble problem, in which I have a bag and there are 3 blue marbles, 4 red marbles, 2 yellow, 2 white, 4 green. And I want to get some of these probabilities. So the first thing I need to do is total all of the marbles up. I come up with 15. So there are 3 out of 15. That's my probability of selecting a blue. 4 out of 15. That's my probability of selecting a red. 2 out of 15 is yellow. 2 out of 15 is white. And 4 out of 15 is green. So I'm going to select 2 marbles without replacement. What is the probability that I get a red and then a yellow? So I'm looking for the probability of a red and then a yellow. Now, first thing is fairly straightforward. What's the probability that I get a red marble? Well, as we calculated before, it's 4 out of 15. And, remember we said and for the most part means to multiply. So I'm going to assume that I've selected that red marble. Now, what's the probability that I select a yellow marble? So I have 1 less because that marble is not going back out or back into the bag. So if I count the remaining marbles, I only have 14 and 2 of them are yellow. So it's 4 out of 15 times 2 out of 14. Notice that the denominator decreased by 1 after I pulled out the first marble. So 4 divided by 15 times 2 divided by 14. I'm going to type it in just like that and get 0.0381. 0.0381. Okay? Return that. Now, new question. If I select 2 marbles, again, without replacement, what's the probability that they're both blue? So that's the probability of a blue and a blue again. So the first blue is pretty straightforward, has a probability of 3 out of 15. Now, again, I'm assuming that I selected that blue marble, and now I want to pick another one. So of the remaining marbles, and there are only 14 because 1 of them is out, now 2 of them are blue. So notice that the numerator decreased by 1 because I'm picking the same color, and the denominator decreased by 1 because I will have 1 less marble. I type that in my calculator, parentheses, 3 divided by 15 times 2 divided by 14, and I get 0.0286. 0.0286. Okay. Moving on. What if I wanted to know, if I select 3 marbles without replacement, what is the probability of 2 red and then a white? So, probability of red and white. Okay, again, first one's pretty easy. What's the probability I select a red marble? So there are 4 red marbles out of 15. Okay, I'm going to assume that the first one I picked was a red one. Okay, so I'm going to bring it down here. Now, again, if I look at this and I count the number of marbles left, I've only got 13 total, or I'm sorry, 14 total, 1 less than I had before, and I only have 3 red marbles left. Okay, 3 red out of the total of 15. So the last one that I'm going to select is now a white marble. So I've already picked this red one. And now I want to know the probability of picking a white one. Well, there's 2 whites, but only 13 total marbles left. So there's 2 white marbles, 13 total, and I'm going to type that right in my calculator. 4 divided by 15, 3 divided by 14, 2 divided by 12. Okay, 0.0095. 0.00 9.5. Okay, so that's a red, and then a white. All right, now we show you a few examples with cards, and that'll wrap it up. So you need to know a couple of things before you can answer these card questions. You need to know that there's 52 total cards. And you need to know that there, whoops, not cars, cards. And you need to know that there are 13 of each suit. That will be helpful for answering these questions. Okay, 3 cards are dealt one at a time. Find the probability of each of the following. So, again, I'm going to select a card. I'm going to deal you a card. And you're going to keep that card. You're not putting that card back in the deck. You're going to keep it, and then I'm going to draw you another one. So, if I get all spades. So first off, I want to figure out, basically I'm looking for spade and spade and spade. So the probability of a spade is 13 out of 52. There are 13 spades out of the entire 52 deck. So the first card, the probability that the first card is a spade is 13 out of 52. Now, you keep that spade. So now there's only 12 left out of 51 cards. And then the third one's got to be a spade, so there's one less out of 50 cards. So again, if the items selected are the same, both the numerator and the denominator will decrease. So 13 out of 52 times 12 out of 51 times 11 out of 50. And I end up with 0.0129. 0.0129. Alright, what's the probability I don't get a spade until the third card? So, that's the probability of no spades, and then a spade. Okay, now if we said the probability of S, or spade, was 13 out of 52, then the probability of no spade is 39 out of 52. If there's 13 spades, there's 39 non-spades. So that's going to be a non-spade first, 39 out of 52. A non-spade again, 38 out of 51. And then the last card has to be a spade. Well, there's still 13 spades left, because for the first two haven't been selecting them, out of 50. And I type that in my calculator. 39 divided by 52 times 38 divided by 51 times 13 divided by 50. And I end up with 0.1453. 0.1453. Okay, last one. I get at least one club. Now remember, at least one is 1 minus none. So it's going to be 1 minus the probability of no clubs. So no club, and no club, and no club. Okay? So that's 1 minus, okay, the probability that I get no club on the first, so that's 39 out of 52. No club again, 38 out of 52. And no club again, 37 out of, whoops, I'm sorry, this should be 51. 38 out of 51. 37 out of 50. Okay, and of course, again, I can type that right in my calculator. 1 minus 39 divided by 52. Whoops. And 38 divided by 51. And 37 divided by 50. And voila, 0.5865. Now, we will continue working with this in class and also throw in some more difficult problems.